Charging by contact between a conductor and insulator. Now, what's different here is one has to initiate a conductor insulator interaction by starting with a charged insulator. This implies that the charged insulator is in a higher energy state initially. So what I'm thinking here is that I'm thinking something like this. I have an uncharged insulator. And so when I'm looking at this, I have a series of potentials and then I have my forbidden regions. And what I have here is that I have charges. And so when I'm looking at this, I'm seeing that the binding energy in this situation is about this big. Now what happens is that you're seeing here that this is a lower energy state. But now as I go through charging by contact, I then have this situation. So I'm going to copy this and bring it over here and paste it right here. What's happened now is that my binding energy for these electrons has changed because now I've added more, I've transferred more of these weak electrons from the weak insulator. So when you're looking at this, the binding energy of these guys is now lower. In essence, they are now in a higher energy state. Now, what we have to do is that we have to compare the energy states of a charged insulator and a grounded conductor. Comparing the energy states of a charged insulator and an isolated conductor. And what I mean by an isolated conductor, that means that the conductor is insulated from the ground. Now, I won't go into more details than this, but that turns out to be really important. But we need other stuff before I can explain that completely. So comparing the energy states of the charged insulator with an isolated conductor, picture-wise, one sees, and so I have this state, which is excited. Right, so this is my excited state. And now I know that this guy here is at a higher energy, right? So this is higher energy. And so when I look at my conductor, I need to compare this to my conductor. And so when I look at my conductor, what I'm seeing here is that, again, this is the forbidden region, and we saw that there was a single effective potential. So when I'm looking at this guy right here, that represents the skin of the metal, right? That's the metal surface. So inside of here, I also have these electrons. So I'm going to come in here and I'm just going to draw them green here again. Just reminding you that that's the way we've been drawing the weakly bound electrons. And so in this situation, we're saying that over here, this is the charged insulator. And this is the isolated conductor. And this represents a lower energy state. Following what we said before, when I compare these two, now we have the same type of process. So the process is identical to an insulator interaction. And that means that we have charging by contact transfers high energy electrons to lower energy conductor. It's about energy transfer. So now what do I see here? I have this situation. So let me copy this. So we know that this is at a higher energy state. I'm going to move this over here. And then I have my conductor right here. And so what you're seeing here is that I'm going to transfer some of these electrons. So when I look at these electrons, what you're seeing here is that some of these are going to go away because they've been transferred. So in other words, I have holes here. And as a consequence, I now get these transferred electrons. And so when I'm looking at this, I now have these negative electrons, and these guys are transferring over to the lower energy conductor. So here, we now transfer. So once again, we play the same game as we did before. We have less electrons. Then it's going to be positively charged. If I have more electrons, it's going to be negatively charged. Now, the thing that we want to pay attention to is that what are the applications of this thing? So the images that I'm going to show you here, I've already drawn them by hand just to save time. And so an application of this is what's called an electroscope. Now, an electroscope is an early instrument to detect the presence of electric charge. And what you're going to find here is that there are two varieties. So again, I've already created these images, so I'm just going to copy them just to save time. So what you're seeing here is that you're seeing two different electroscopes right here. Now, one of the things, remember how I said, well, here, let's talk about this first. So right here, this is a conducting plate. Sometimes they use a conducting ball. In fact, it's probably more common for a conducting ball. I prefer the plate. Now, when you look at these electroscopes, what you're seeing here is that that conductor is connected down here. And what you're finding here is in the early days, they used to use gold leaf, but now you can use aluminum foil. And I'm going to suggest that you actually build one at home. And then over here, what you're finding here is that you have the blue piece and you have the gray piece. These are aluminum, I guess, I call them needles that are ultra sensitive to electric charge. And what you're going to find here is that right here, at this point right here, there's a pivot right here. In fact, I might draw this in yellow just so it could stick out. This right here, right in here, it pivots about this axis. And what you're seeing here is that this guy is a conductor, the black is a conductor, and note right here, this is an insulator. And what the insulator does is that it isolates the conductor from the ground. If you didn't have that, it turns out that the conductor would not charge up. So now, here's what we're going to do. I'm going to have the exact same situation. So I'm going to come in here and I'm going to paste this guy right here. And I'm going to move this guy down here. And in fact, I'm going to copy this just to set up. So what's going to happen here is that we're going to do the following thing. Actually, I need a little bit more space. So let me move this down. I need to move this down. So what has to happen here is that one has to start with an initially charged insulator. And in this case, I'm going to use a PVC rod because that's what you have. You have a PVC rod. And so now what's going to happen here is that we're going to make contact with the conducting plate or ball where now there is a transfer of electrons from the rod to the electroscope. So here's what I'm thinking here. So I imagine that I have a rod. Let's bring this here. So I'm going to come in here and I already have a charged rod. And all I know is that there's a lot of charges here. So if I look at this, I have excess amounts of charge. So now note that there are positive charges too, but this just represents the excess charge. So now what we're going to do here is that right here, we're going to make contact. So when you make contact, this is what ends up happening. I'm going to take my rod, I'm going to paste it back here. I've made contact and now I move away. And so what you're seeing here is that now we have now lost electrons. And when you lose electrons, they transfer through the conductor and they try to get as far away as possible. So in other words, I'm going to have charges here and here, and because it's so lightweight, I end up getting repulsion between the two aluminum sheets. In other words, we're doing charge transfer via charging by contact. And the reason why it occurs is it's moving charge from higher energy to lower energy. Now I can repeat the same process here with this style of electroscope. So if I do the same type of thing here, then I'm going to paste my charge rod right here. Actually, I need to make a copy of this. And so what actually happens? So I have my charge rod. Again, I'm going to make contact with the metal here. And oops, I'm going to take this guy away. And then what ends up happening is I'm going to move this guy away here. So as I move it away, what happens here is that some of the charge now goes onto the metal plate. And as it goes onto the metal plate, these rods repel each other relative to that pivot right there. And the reason why they repel is because charges here are also charges on the blue part of the rod. In other words, these guys continue to move until equilibrium. So now what you're seeing here is that you're seeing between here and here, and here and here, I get repulsion. In other words, so when I'm looking at this guy, I get this process where I get charging by friction here. So these two do exactly the same thing. Now, what I want to show you here is that I want to show you a video. And this video here, we have a charged rod making contact with the electroscopes. So let me go share my screen so you could see what I'm talking about. So here we go. So let's play this guy.
And then if we touch this sphere here, the two little pieces of aluminum foil separate, and demonstrating that both of them have acquired some negative charge, some electrons, and are now repelling each other. You can also use a very sensitive Braun electroscope to measure minute amounts of charge. And basically, this is doing the same thing that the two pieces of aluminum foil were doing. But in this case, you have a piece of metal here and metal here, both with the same charge repelling each other and causing the needle to shift.